Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single math problems from this book. If you're interested in watching any one of the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems, and we are on page number 162. The very first problem on the page. The very first problem on the page, number 71. We have total of 2,420 stocks, we are told. We are told that 20% more closed higher. 20% more closed higher. Let's use letter H to represent the number of stocks that closed higher than the number that closed lower. Let's use letter L to represent the number of stocks that closed lower on a given day in the market. And 20% closed higher, which means the number of stocks that closed higher is 20% more, 1.2 times L. We also know that the total is 2420. If the total is 2420, that means H plus L is 2420. We are looking for the number of stocks that closed higher. It's pretty straightforward, pretty simple now. We have two equations here. H plus L equals 2420 and H equals 1.2. We we substitute the value of H from here in this equation, we are done. H is 1.2 times L. So 1.2 L plus L equals 2420. That means 2.2 L equals 2420. Which means L equals 2420 over 2.2, which is same as 24. I multiply the top and bottom by 10, and when you multiply top and bottom by 10, this is going to end up with one more zero. But instead of leaving everything together, I broke it up 242 times 100. You will see in a second why. Because it's easier to divide this number by 22 instead of worrying about the 100 there. So let's do it then. How many 22s? How many 22s in a 24? 24 has only one 22. 24 has only one 22. The remaining 2 goes and joins the 2 and becomes 22 again. And that 22 has one 22. But there you go. It's 11 times 100, which is 1100. 1100. That's how many closed lower. What we are interested in is how many closed higher. Well, the number that closed higher is the number that closed lower, which is 1100, and at 20% more. Right here, 20% more. 10% of 1100 is 110. 20% is going to be 220. Something has gone wrong. What the hell? I have to learn how to add. See, that's what happens when you try to explain too much. It's 1100 plus 220, obviously. 1100 plus 200 is 1300, is 1320. That's it. That's your answer. Let's do the next one, shall we? Number 72. Number 72. In number 72, we are told that y times 3x minus 5 over 2 equals y. We are also told that y does not equal 0. The question is, what's the value of x? What's the value of x? Now, why do you suppose they go through the bother of telling us that y does not equal 0? Do you do you appreciate the significance of this statement? Why is it important that we know that y is not equal to 0? Because if y were equal to 0, listen carefully, because if y were, one is speaking hypothetically right now, if y were equal to 0, we would not have been able to divide both sides by y, because you can't divide anything by 0. Okay, I'm not going to actually do it out in a baby way, but that's what we're going to do. We're going to divide both sides of the equation. We're going to divide both sides of the equation by y, and the y is going to drop out. And we end up with 3x minus 5 over 2 equals 1, which is same as saying 3x minus 5 equals 2. Add 5 to both sides, and we end up with 3x equals 7, and therefore x equals 7 over 3. Divide by 3, x equals 7 over 3. Let's go to the next one, number 73. Number 73. The question is, what's the value of x? Let's do it on the top. We're looking for the value of x, and we are told that x plus 5 is more than 2 and x minus 3 is less than 7. Well, let's find out, shall we? If x plus 5 is more than 2, if we can add 5 to both sides, and that tells us that x has to be more than 7. Here, let's add 3 to both sides, and that tells us that x has to be less than 10. It cannot be more than 7 and less than 7, obviously. That will be a null set. So that's it, we're done. Something is going wrong. Did I make a mistake here? We added 3 to both sides, and that's 10. Did I make a mistake here? I made a mistake here, didn't I? Because that's not what my notes tells me. We are not adding 5 to both sides. We have to get rid of this 5, and we need to subtract 5 from both sides. I hope and pray to God that 7 to 10 is not one of the answer choices. Otherwise, if 7 to 10 is one of the answer choices, then I'm screwed. Well, lucky for me, it's not there. They do not say 7 and 10. So, if we subtract 5 from both sides, this is going to end up with negative 3. Had they said from 7 to 10 as one of the answer choices, and if I were not careful, I may have picked that one, because that's what I ended up with. I'm surprised they do not give you that as one of the answer choices. They should have, because it's a very simple mistake. It's a very, very easy mistake to make for those people who do not have the concentration, such as myself. Let's continue. So that's it, we're done. X has to be between negative 3 and 10. Here is our x. This has to be more than negative 3 and less than 10. X has to be between negative 3 and 10. Let's do the next one. Number 74. Number 74. We are told that n is the number of students. N is the number of students, and we are told that they can be divided into 8 equal parts or 12 equal parts. This being a number of students, it has to be evenly divisible. It has to be an integer. Understand? Otherwise, we'll end up with a complaint from a parent if we end up with 2.3 children. Very difficult to be a child if it's 2.3. The question is, what's the lowest possible value of n? the lowest possible value of n that they speak of here, the lowest possible value of n that they speak of here is what mathematicians would call LCM, the lowest common multiplier. LCM, lowest common multiplier. And how do we find the lowest common multiplier of two numbers, of 8 and 12? 8 and 12. This is how we do it. We start dividing them until we end up with a prime number at the very bottom. At the very bottom we have to end up with a prime number. These are not prime numbers. Had 8 and 12 been prime numbers, then their lowest common multiplier would simply have been the product of these two numbers. The lowest common multiplier of 3 and 5 is simply 15. That's the smallest number that you can find that you can divide evenly by 3 and 5. These are not prime numbers. So we're going to have to start dividing until we find prime numbers at the bottom. Let's divide both of these numbers by 2. And again, these are not prime numbers. Let's divide again by 2. And that's it. That's the end of the story. That's the end of the story. This is a prime number and this is a prime number. That's where the story ends. So the lowest common multiplier, is simply 2 times 2 times 2 times 3. That's it, we are done. 2 times 2 times 2 is 8. 8 times 3 is 24. 24 is the smallest number that you will find. 24 is the smallest number that we'll find that we can divide evenly by 8 and 12. That's the smallest number. Of course, there are infinite other numbers, but this is the smallest one. Hence the lowest common multiplier. It's not the only multiplier. The next one, of course, will be 48. Or maybe I missed something in between. Who knows? But this is the smallest one. Yes, 36. No, 36 would not do it. Yes, 48 would be the next one. Anyway, the smallest one here is 24. LCM, lowest common multiplier. Let's go on to the next one. The one about the triangle, the equilateral triangle. Number 75. We are told that we have an equilateral triangle. Triangle ABC is an equilateral triangle. We are told that point P is equidistant from the three vertices A, B, and C. Let's draw the triangle, shall we? So we're going to do an equilateral triangle such that the point B sits right in the middle of the triangle such that it is equidistant from these three vertices. Let's do it on the side here so I have room to work. Right here is my point. Let's call it A, B, and C. That is just point P. Alright, so far so good. I don't know what they are looking for. So we're going to rotate. The triangle is going to be rotated clockwise about point P, and hence the significance of point P. We're going to rotate the triangle about this point clockwise. The question is, what is the minimum degree the triangle must be rotated so that B ends up where A is now? It's a very long question, lot to write here, but there is not much in there. And now that I have written everything, I have left no room for myself to work, so I'm going to have to erase part of the question. So here's what's going on. We have an equilateral triangle. Point P is the center of the triangle. We're going to rotate this triangle about this point clockwise, and the question is, we want this point to end up right here where point A is. Let's do it on the top. Well, first we're going to go from B to C. B to C is a third of a circle. Once this point is at point right here, once the point B ends up here, we're going to move it from C to A. And C to A is another third. That's all it is. It's not much there. So in order for the point B to end up where point A is, in order for point B to end up where point A is, we have to move 2/3 of the circle. A third of a circle is 120 degrees, we know, because the whole circle is 360 and a third of a 360 is 120. A third of a circle is 120, therefore 2/3 is going to be 2 times as much. The answer is we're going to have to rotate it 240 degrees. We're going to have to rotate it 240 degrees clockwise. We are rotating it clockwise. Had we been permitted to look, had they not specified a direction, and had it been up to us to rotate whichever way we wanted, then the minimum degrees that we would have rotated is 120 degrees from here to here. Anti-clockwise. Anti-clockwise. Or as you guys call it, the counterclockwise. That's it. Let's do the very last one, number 76. Number 76. We are told that at least 2/3 have to vote in favor. We are also told that we have a total of 40 people. The question is, how many people can vote against a given measure and still it passes? In other words, we have to figure out what is 2/3 of this guy here. 40 times 2/3. 40 times 2/3. Well, let's divide it, shall we? How many threes in a 4? 4 has 1 3. 4 has 1 3. The remaining one goes and joins the 10. The remaining one goes and joins the 10 and becomes. Remaining one goes and joins the 0 and becomes a 10. How many threes in a 10? 10 has 3 threes. 10 has 3 threes, and we have a remainder of 1, which is being divided by 3. 13 and 1/3 times 2. 13 and 1/3 times 2 is same as 13 times 2 is 26, and 2 times a third is 2/3. But obviously we can't have 26 and 2/3 of a person. Therefore, this translates to 27 people. The fact that we need at least 2/3 of the people to vote in favor, the fact that we need at least 2/3 of the people to vote in favor, and given the fact that there are exactly 40 people sitting there, which means the minimum of 27 people have to vote in favor. Minimum of 27 people have to vote in favor. We have a total of 40, therefore 40 minus 27, 13 can vote against. If 14 people voted against the measure, it will not pass, because we will not have the 2/3 majority. We need a 2/3 majority for it to pass, and the 2/3 majority of 40 is 27. That's all. I'll see you tomorrow, okay? Bye now.